non-metals. So they bond differently. They share their electrons. So as you can see here, their electrons are being shared. The last fundamental concept or idea for this section of the chemistry is about what happens in these reactions. What happens to the molecules? And a really important point is up here at the top. It says that no atoms are lost or made during a chemical reaction. So the mass of the product equals the mass of the reactants. So if you look down here, just say for example you've got 5 grams of oxygen reacting with 6 grams of methane. In total, you've got 11 grams. If 11 grams are reacting together, it could be of anything, if they react together, you're always going to get 11 grams out in the products. So in this case, you've got 7 grams of carbon dioxide and 4 grams of water. So whatever mass goes into the equation, you get the same mass coming out, because no atoms are lost or made during a chemical reaction. Now what you need to be able to do is balance symbol equations to show the different amounts of atoms at each stage of the reaction. And to get this properly, you just need practice. So what we've got here is oxygen and methane reacting together to make carbon dioxide and water. And what I've done underneath is put the chemical formulas. So I've got O2 for oxygen, CH4 for methane, CO2 for carbon dioxide, and H2O for water. The way that I like to do this is first start by counting up all the different types of atoms on each side of the equation. So if we draw a little line down there, first we're going to focus on the left-hand side. So on this side of the equation, I've got at the moment 2 atoms of oxygen. Then I look to see how many atoms of carbon I've got. And I've only got 1. And finally, I look at how many atoms of hydrogen I've got, and at the moment I've got 4. Then what I like to do is go to the other side and count them all up there. How many oxygen atoms have I got? 2 there and 1 there, so I've got 3. How many carbon atoms have I got? 1 here. And how many hydrogens have I got? I've got 2. Now if we look at these, what we should see is that these aren't the same. So I've got 2 oxygen atoms over here, but 3 over here. I've got 1 carbon over here and 1 carbon over here, and they are the same, so the carbons are balanced. And I've got 4 hydrogens over here and 2 hydrogens over here, so they're not balanced. So they need to be the same, and they need to be the same. So what we need to do is add some more molecules into this reaction to make it balance out. So to start with, what I'm going to do is have a look at the hydrogens. So there's 4 hydrogens over here, 2 over here. I need another 2 hydrogens over here to make 4. So what we do is we add in another molecule of water. So I did have 1 molecule of water, now I've got 2. And if I was to draw it, although the picture will be rubbish, is what I would have is just another water molecule. Once you've done that, you need to count up all your atoms again. So on this side, on the right hand side of the equation, we've now got a different amount of oxygens. So we've got 2 oxygens there, and now we've got 2 oxygens in the water molecules. So 2 plus 2 gives us 4, so that changes to a 4. We haven't changed the amount of carbons. Our hydrogens have changed, so we do 2 times 2, which gives us 4. Or you can count them up in the picture. It'd be 1, 2, 3, 4. And now, if you have a little look, our hydrogens are the same. Our carbons have always been the same. So what we now need to do is balance these oxygens. We've got 2 oxygens over here, 4 oxygens over here. And we can do that by adding in another oxygen molecule. And if I was to draw that, it would look a little bit like that, although it's not very good drawing. And we can now count up our oxygens again. 1, 2, 3, 4. So we've got 4 oxygens there, or 2 times 2 is 4. Are the oxygens balanced? Yes, they're the same. Are the carbons balanced? Yes, they're the same. Are the hydrogens balanced? Yes, they're the same. So we've balanced our equation. Now it's your turn, so you need to pause the video and you need to try and balance the 2 chemical equations below. Hopefully you've managed to have a good go at those. So let's just go through the answers. In the first question, if we're to split up our reactants and our products, we've got magnesium reacting with oxygen to make magnesium oxide, or MgO. What we're going to do first is count up the atoms on the left-hand side of the equation. So the number of Mg, or magnesium atoms, is 1, and the number of oxygen atoms equals 2. So there's 2 oxygen atoms in that molecule of oxygen. Over on the right hand side then, we've got 1 magnesium atom, and we've got 1 oxygen atom. So hopefully what you can see is that our magnesiums are balanced, they're the same, but our oxygens aren't balanced. So what we need to do then is increase the number of oxygens on this side. And the way that we do that is by adding another molecule of magnesium oxide. So now if we count up our atoms again, now we've got 2 magnesiums on this side of the equation, and now we've got 2 oxygens. So if we look, we've got 2 oxygens over here, 2 oxygens over here, so that's balanced. But now what we need to do is do something about the magnesiums, because they're not balanced now. So to do that, what we do is add another magnesium, so that we've got 2 magnesiums on this side, on the left hand side, and then 2 magnesiums on the right hand side. So now here, they're balanced. The next equation is a bit trickier, but if we do the same thing again, if we count up the atoms on the left hand side, we've got 1 atom of iron, and we've got 2 atoms of oxygen. On the right hand side, we've got 2 iron atoms and 3 oxygen atoms. So what we need to do is increase the number of iron atoms on here, because there's 2 on this side and 1 on that side, and we need to increase the number of oxygen atoms on this side as well. If we first look this time at the oxygen atoms, then if I was to add another oxygen molecule here to make it 2O2, then I'd end up with 4 oxygen atoms in total. But if we look on the right hand side, there's 3 oxygen atoms there. So that still doesn't solve our problem. It still doesn't balance the equation. So what we need to do this time is add another molecule of iron oxide over here. Now this changes things quite a lot. So you need to count up your atoms again. You've got 2 times 2, so you've got 4 iron atoms on the right hand side, and you've got 2 times 3 oxygen atoms, so you've got 6 oxygens now.